Looping statements in synthesis. In the previous session, you learned about the circuit generated by branching statements like if and case. Now you will see what will be the effect on the generated circuit if you add any loop statements like for and while. To determine what hardware will be inferred for a loop, the rule is quite simple. Just duplicate the loop body by the number of iterations, and make the loop variable a constant in body of each iteration. Duplicating the body of a loop is called loop unrolling and is an important technique in code optimization. Let's look into an example. Here is a module with name my_design. It has two inputs, ports A and B, which are of with 4, and a single bit output named X. In the always_comb block, first the output X is assigned with value 0. Next is a for loop with 4 iterations with looping variable I changing from 0 to 3. The expression is X equals X OR with exclusive OR of A of I and B of I. Finally, X is negated after the for statement. To understand the circuit produced by this program, let's apply these rules. Unroll the loop, and replace the looping variable I with its constant value in every unrolling. It is shown here. It replicate this statement 4 times and replaces I with its value in every unrolling, which are 0, 1, 2 and 3. Note that, this loop unrolling will be done by the synthesizing tool and not by you. Now it is easy to draw the circuit produced by this for loop. It is shown here. First X will be assigned with 0 and is given to an OR gate input, whose other input is the output of an XOR of A of 0 and B of 0. This X is passed to the next level of circuit, which is equivalent to the second iteration of the for loop, and this is repeated 4 times. Finally, X is passed through a NOT gate to generate the last statement in the always block. This is the circuit generated by the for loop. Note that this circuit will be optimized by the synthesizing tool and you will see only its optimized version in the final output of synthesis.